Today's lesson is lesson 2.5, and it's the graph of y equals kx squared. On lesson 2.4, we did the graph of y equals kx, so now we're doing y equals kx squared. So let's go through some examples so you can see what this graph looks like. Example 1, find the following rates of change and explain what each means in terms of braking distance. So in 2.4, we talked about rate of change, and that is the slope of the line. So we're going to figure out the slope of the line and then explain what those rates of change or that slope means in terms of braking distance. So part A, R1, the rate of change from 20, 20 to 40, 80. So we know that slope is the rate of change, so we can say R1 equals 80 minus 20. So I'm going to do 80 minus 20 and then 40 minus 20. 40 and 20. Make sure you always do them in the same order. And that equals 60 over 20. And that equals 3. And the units in this case are feet per mile per hour, because we were doing braking distance and then over speed. So this means that on average, when driving between 20 and 40 miles per hour, so that was that x1 and x2, when you're driving between 20 and 40 miles per hour, for every increase of 1 mile per hour in speed, you need 3 more feet to stop the car, and that's what that means. Every 1 more mile per hour, you need 3 more feet to stop the car. So let's look at this on the graph. So we were doing between 80, well, the first point was 20, 20, so it was this one. And the second one was 40, 80. So between those points on that curve, you need, for every increase, for every 1 mile per hour it goes up in speed, you need 3 more feet to stop the car. That's what that means. So let's do R2 now. The rate of change from 40 to 80, 40, 80 to 60, 180. So now we're going to do 40, 80 to 60, 180. And let's see what that one's going to mean. So R2 equals 180 minus 80. So I did the 180 and the 80. And then 60 minus 40. So I did the 60 and the 40. 180 minus 80 is 100. 60 minus 4 is 20. That is 5 feet per mile per hour. So from the square on the graph to the next square on the graph, you can see I'm putting the squares around those points. From those 2 points, so in other words, from between 40 miles per hour and 60 miles per hour, so 40 and 60, you're going to need 5 feet of braking distance in this case. Not just 3, now it's 5, because that curve is getting steeper. And then part 3, actually it's part C, and it's R3, the rate of change from 10, 5. So now we're down here to 20, 20. So now we're going to look at those 2 points, the 2 triangle points I just did. So R3 equals 20 minus 5 over 20 minus 10, and that equals 15 over 10, which equals 1.5 feet per mile per hour. So from 10 miles per hour to 20 miles per hour, you only need 1.5 more feet to stop your car. And then finally, part D, R4, the rate of change from 20, we'll do another circle, 20, 20, to 50, 125. So from 20 miles per hour to 50 miles per hour. So R4 equals 125 minus 20 over 50 minus 20. 125 minus 20 is 105 divided by 30. And that is 3.5 feet per mile per hour. So from 20 miles per hour to 50 miles per hour, you need 3.5 feet for every mile per hour in between there, 3.5 feet of braking distance.